right, so for those that may have missed the calculator piece or just need to review, pardon me, here we go. So in the bottom left-hand corner, there is an on button. Yeah, now remember down here, the key press history shows up. So if you get lost, check down there. You can also just pause the video, yeah? All right, so we need to put in our function. Up in the upper left-hand corner, you'll see y equals. Be careful, because if 1, 2, or all 3 of your plots at the top are highlighted, in other words, if they have a dark background, that means that your calculator is looking for statistical data. It wants to graph a box and whisker plot. It wants to graph a line graph. It's going to look for a list of numbers, which we are not putting into our calculator. So you need to unhighlight them. Just put your cursor up on one of them and press enter, and it will change them to not be highlighted. If you have any functions in here, press clear. It's to the right-hand side, and start with a fresh slate. Okay, for the calculator review warm-up function, we need to put in our -1/2 x to the 5th, our first term. If your first term is negative, you have to use the negative symbol down here. You don't want to use the subtraction symbol. You're not subtracting from anything, so your calculator is going to get confused. If you have a newer version of a calculator, of your TI, and you hit alpha, y equals, you might have the option to put in a fraction in fraction form. Not everybody has this, but if you do, woo-hoo, you're excited. So put in 1 for the numerator, arrow down to 2, and then you have to arrow out of the fraction in order to put in your variable. Now again, not everybody has this, so if you find yourself not having that option, easy peasy. We're just going to open our parenthesis. It's above the 8. We're going to put in 1 divided by 2 because fractions are division, and then we're going to close the parenthesis, which is above the 9. For our variable, we're going to use the button to the right of alpha. It says x, tau, theta, n. We're going to use it for x, and then we're going to raise it to the 5th power based off the equation on our warm-up. So we're going to go to the right-hand side underneath clear. You'll see the upside down V. We call it a caret. And we're going to put in a 5. If your cursor's still up in the exponential spot like mine is, just arrow to the right to come back down. All right, now we're going to subtract, so now you can use the subtraction sign. Again, open parentheses, 19 divided by 12, numerator divided by denominator, x, raise it to the 4th, using our upside down V, and then I'm going to arrow back down. We then need to add parentheses 7 divided by 2. That x is up here again to the right of alpha. Now for the cube, yes, you can use that upside down V again. Or we can go to math. Math is underneath alpha on the left-hand side. And you can press number 3 because that is a cube as well, and it'll automatically put a cube for you. Then our next term, we're going to add open parentheses 65 divided by 12, close parentheses, x squared. Here you have also an option. Yes, use the caret, raise it to the 2nd power, or on the left-hand side, you can hit the squared button. It is in the row above 7, 8, 9, all the way to the left. We then are going to subtract x. No parentheses needed because we're not dealing with any fractions. And then we're going to subtract parentheses 7 divided by 3, close parentheses. Whew! We made it through. But the purpose of making it through is so we can graph it. Graph is in the upper right-hand corner. And there's my pretty graph. Now, if you have borrowed a calculator, you've used your calculator recently, and your window is funky, you're like, nope. Go to Zoom. It's in that top row in the middle. And number 6, standard, is going to reset your window so that your x-axis goes from -10 to 10 and your y-axis goes from -10 to 10. If you would like to zoom more in or out, you can play around with the zoom window. I personally, when adjusting my window, like to use the window button because it allows me to manually adjust my window rather than sitting there trying to play with my zoom in and zoom out, hoping to get the right adjustment picture. Looking at the function we have right now, I'm going to adjust my x-axis. So I'm going to hit Window. Here we have our options. What do I want my minimum to be? I want it to be -5. That's the smallest value for my x-axis, and I'm going to press Enter. I'd like my x maximum to be 5. Now the scale means, what does every tick mark represent? It represents 1 unit for both the x and the y scale, and I'm going to keep it like that. I don't usually mess around with that too much. Going back, hitting Graph, I can see this is so nice. I can see where the function does and does not hit the x-axis, and I get an idea of where the curves are. First thing we want to find is the y-intercept. In that top row to the left of Graph, there's a button that says Trace. Above that, for my calculator, it's in blue. Yours might be in yellow or green, depending on the version. But those are called your second function. So I'm going to hit Second Trace, and it gives me a whole bunch of characteristics that my calculator will calculate for me. For the y-intercept, you want to choose number 1. So I'm going to hit Enter. When you have a y-intercept, the x-coordinate is 0. So I want my calculator to tell me what the y-coordinate is when x is 0. So I put in 0, and I'm going to press Enter. Boom. At the bottom, it tells me right where my cursor is. It's at 0, -2.33. Please, at this moment, write that down. Feel free to pause the video if needed. Write that down on your warm-up in coordinate form, 0, -2.33. The next thing I'm going to find, and that's why I said pause, because I'm moving on, are the x-intercepts. And it looks as if there's 1, 2, 3 of them. So I'm going to do the first 2 with you, and then I'm going to pause my video while you find that third one, okay? So I'm going to go to Second Trace. Remember, your x-intercepts are your roots, your solutions, your your zeros. So I'm going to go to number 2 and press Enter. Now your calculator views this graph as an infinite amount of x and y coordinates. It's not going to search for all of your x-intercepts. No, it's friendly and helpful, but not that helpful. So we need to give your calculator an area to search. Notice it says left boundary. So my cursor is right here. Again, at the bottom of your screen, it tells you where your cursor is. And I'm going to use my arrows to go to the left to that first x-intercept. Holy heck, I can't see at all my cursor. But remember, you can see it down here. Okay? So here we go. I'm going to the, where did my cursor go? Holy heck, I have a bad feeling I'm off. I'm going to second quit. I'm going to go back to my graph, and I'm going to try this one more time. So Second Trace, I'm going to go to 0. Why is it so far down and over? Goodness gracious. Okay, I'm going to pause my video real quick. Hi everyone. Okay, so I went back to my y equals in the upper left-hand corner and just double-checked that I entered in my function correctly, that all the fractions were correct, the pluses and minuses and the exponents, and everything looked fine. So I went back and I reset my window. I went to Zoom Standard number 6, and I couldn't find anything. So the graph looked normal. I then went to Window and set my x-axis to go from -5 to 5 again. Here we go. So, yikes. I went to Second Trace and hit 0. Here's my cursor. I'm hoping that it'll go along the function. There we go. That was so strange. All right. I need to be, or maybe that was just me having a moment. Today's been a day, let me tell you. Hoi. I need to be to the left of this x-intercept, so I'm above. That's to the left. I'm going to hit Enter. It now is bringing up an arrow and a dashed line. Some some calculators will give you a dashed line. Some will give you an arrow. Some will give you both. Okay, it just shows where you marked. Now I'm going to go to the right of my x-intercept, which is below, and I'm going to hit Enter. Again, it brings up an arrow, and your calculator wants you to double check. So is this where you want to check? And you're going to hit Enter for the 3rd time, and it tells you that your 0 is approximately -4.21, 0. Please make sure you write it in coordinate form, and that you are rounding to the hundredths, 2 decimal places. Okay, if you need to pause the video, please do. I'm going to keep going. I'm going to find this second x-intercept. So I'm going to hit second trace, and I'm going to hit number 2 again. And I'm going to go to the left of that x-intercept. Now, I can't see my cursor, but I know it's at negative 3.6, comma, negative 54.3. Here we go. It looks like it's coming back up because my y values are getting bigger. All right, so I need to be to the left. That looks like it's about to the left. I'm going to hit enter. Again, my arrow and my my dotted line pop up, and then I'm going to go to the right and hit enter. Your calculator shows you where you marked, what region you've marked. Is this where you want to guess? You're going to press enter for the 3rd time, and it tells you that your 0 is approximately 0.66, comma, 0. Please write your x-intercept rounded to the 2nd decimal place to the hundredths and in a coordinate. All right, pause the video, please. Find that 3rd x-intercept on your own. Welcome back. Hopefully you found it. Now, notice at the bottom, I have 2.4 e. That's not eek. Not e for eek. What that is scientific notation because your calculator did its best with the region you gave it to find the x-intercept. That means that it is 0.000000000024. That's approximately 0. So go ahead and write 2.11, comma 0. Now the next things we need to find are the local min, local max, absolutes if they exist, and then the increasing and decreasing intervals. Pardon me. Now, for increasing and decreasing intervals, you need the x-coordinates of your maximums and your minimums. So let's find the first minimum on the left-hand side. I'm going to hit second trace, and I'm going to hit number 3 for minimum. Again, I have to give my calculator a region to search in. So I'm going to move to the left. And now I'm off the screen, but that's okay. Watch your y coordinate. Negative 58. Oh, negative 57. It's coming back up. So I'm going to hit enter, even though I can't see my cursor, but I see my arrow and my line. And then I'm going to move to the right. Again, it's getting closer to the x-axis. We're getting closer to the y-axis because my x values are getting smaller. So I'm going to hit enter. Well, sorry, they're getting bigger. They're getting closer to 0. And the calculator says, is this where you want to guess? And I'm going to say yes, so I'm going to hit enter. Our first minimum is at negative 58 The first minimum is negative 58.30 at x equals negative 3.39. Remember, what is the minimum and where does it occur? All right, so write that down on your warm-up, please. Find that second minimum, pause the video, and then come back and check with me. Hello? All right, hopefully you found your second minimum was, or is, negative 2.38 at x equals 0.09. All right, for our maximums, I'm going to hit second trace. Yep, same process. I'm going to hit number 4, and I need to give my calculator a region to search. So again, I'm going to go and kind of bound that maximum. I'm going to go to the left and hit enter. I'm going to go to the right of that curve, that maximum curve, and hit enter. I'm going to hit enter a 3rd time so my calculator will guess, and that maximum is approximately negative 0.32 at x equals negative 0.85. Again, pause the video. Try the second maximum on your own. Hello! Hopefully you found that that maximum is 8.66 at x equals 1.62. If you struggled with finding the x-intercept or the minimum or the maximum on your own, you need to go back. You need to go back to the video and see what I did function clicking-wise, we'll say, keystroke-wise, and practice again on your own. Now, the reason we found, absolute min and max. These were the locals. Locals represent every maximum and every minimum on your function. From there, you have to decide if there's an absolute. The absolute minimum is the lowest point. The function does not surpass that. The absolute maximum is the highest point. The function does not surpass that. So looking at this, our left end behavior goes to positive infinity, and our right end behavior goes to negative infinity. So our graph surpasses all maxes and mins. There are no absolutes. Go ahead and put none for both. Think about what type of function, what type of polynomial creates opposite end behavior. Yep, odd degreed functions. So that makes sense that since this has an odd degree of 5, the function does not have any absolute maxes or mins. Last but not least, increasing and decreasing intervals. Remember that they are always addressed with the x coordinates of your maxes and your mins. We say that the function is increasing from x equals 2 to 5, whatever that might be. So looking at our increasing intervals, we're going to say it increases from negative 3.39 to negative 0.85. It then increases from 0.09 to 1.62. Again, the x values of our maxes and our mins, always working left to right. Our first decreasing interval is going to go from negative infinity to negative 3.39, and then from negative 0.85 to 0.09, and then from 1.62 to infinity. Hopefully this was helpful for those that were not in class, and even for those that were, pardon me, and watched this for extra help. Please write down any questions and ask me when I see you. Have a great day, everyone.